This is a Facit model LX. They made this from, I guess, like the late 30s to early 50s. This one's really one of the kind of more unique ones. They have the extended movable carriage up here, but then also this movable input. So you have a lot of control over like the relative motion of the numbers here. And I think this one was kind of marketed for scientific use where you needed to have, I guess, 19 digits up here for really long numbers that were uh, also ones that you have to do quite a bit of cranking. So you had to really want. Oh, okay, yeah. So it's not quite. There we go. Like I said, lots of cranking, but it was worth it for those 19 digits of accuracy with this one. This one, I got it from London, not London. I got it from England. It says London on there, and it also says a bunch of other places that are London adjacent, I think, like Southampton. I don't know where that is. But uh, pretty much everything works. I mean, this is really, we don't get facets in the States because well, now you have to pay tariffs as well as, you know, shipping from Southampton or wherever. But, I mean, this thing I don't think has been lubricated or worked on in a very long time, and yet pretty much everything besides there's a couple things where this carriage won't lock into the position quite right, and then this button has been, I mean, it does in fact move it over, but it's not, just going back up. This is the only calculator I've worked on so far that didn't already have like a YouTube video, at least one on that model. I mean, I couldn't even find any that have ones that have the sliding carriage up here. So, I mean, the responsibility of that is not lost on me. And, I need to be an ambassador for the mechanical calculator community with this one. So, not only am I going to be committed to thoroughly documenting this process and trying to produce something that is going to be a reference for people for years to come, but I also wanted to announce my commitment to safety on this one. I will be wearing, at a minimum, a safety vest, high visibility, as well as a full brim hard hat. All energy sources will be lockout, tagout, including compressed gas whenever in use. General hand tools will be inspected before work is performed. Let's see, anytime hot work, like a cutting torch, will be used, a hot work permit will be pulled as well as a pre-task plan. Electrical tools, anytime I'm using any cutting abrasive wheels like this, the guards will be properly in place. And okay, removing this carriage is a little involved, mostly just with all of these, everything is press fit. So like there's screws, but you also, in my case, I had to get like a screwdriver and a hammer and a bunch of different stuff to get these out. Um, but starting at the top with this thing, there's this bracket right here, and this, it's screwed in. It kind of hinges on this point here. It goes in through the top of this plate in the back. So these are going to have to be removed in order to get to where we're able to take this thing off. Basically, this is going to hold it to the top, but then there's also, I'm going to take the carriage out here, these little aluminum cast like hooks that ride in the bottom lip of this back plate. So these have to come off in order for this to come out, and then I had to loosen this entire back plate. It's held on by 4 screws, and then also the little press fit pins, these are a little easier, I think, than the the brackets. I'll get to that in a second. But loosening this, I was able to unhook it from there. The thing that was probably the most challenging about this was removing the little brackets that this slides in on either side. The only one that needed to be removed was this one on this side. So from this side, the carriage can slide far enough to the left. So like this will be able to go, like this rides in there, you'll be able to get it like right there to where it can lift out. But I needed to remove, and this was just the best way I could find to do it here. I needed to remove this bracket from this side. So it was kind of a process of first removing the things that held the carriage on top of this little plate, then removing this bracket here, which this one was required the most hammering out of any of the brackets. These little press fit pins in here were very hard to get out. But this thing has a lip, so being able to get a screwdriver and to like beat on it from this direction was able to get it freed up eventually. And once that was done, I was able to slide that out and remove it. So in terms of like complexity, really not that bad, but it was pretty hard to get a lot of these screws out. I mean, I had to use a grinder on, I think, this one to like make a face for me to grab onto with a wrench. Um, I'm going to try to take the input out next. Try to get to the like, I need to be able to get that out to get to this area over here, which is where my problem is. I still don't know why this is. It seemed like such a simple fix at first, but like I'm really gonna have to get all the way in there to find out why this is so hard to do. But this one is just totally fine. Okay, so I figured out the issue with the carriage shift lever thing. So here's a bottom view, and that's the one on the left. Here's the one on the right. And these things kind of, they don't really protrude. I mean, they're basically flush with the bottom of this plate here. But the issue was not anything in the entire, whatever, actual mechanism here. It was with this bottom plate, which was, I had to let the screws that hold this in here soak. Like I basically just poured PD Blaster in it and let it soak for like 2 weeks before I could get this thing off. But I don't know why this indented inwards, but you can see on this one I have this like kind of whatever. It's like it's been chipped away at by the, what is it? This one right here was like impinging on it a little bit. Oh, I can't really see that. This one was impinging on it just slightly enough for this to be an issue. I I don't really, or no, it was, sorry, it was this one. So I'm not really sure what to do about that. This thing is incredibly hard. I don't, oh shoot. Okay, yeah. I don't, this, whatever this was made of, I think it was probably rubber at some point, but we're not doing good with this. Maybe I'll put some plexiglass in there, but I don't know. I don't know how to like unvulcanize and then revulcanize this. I'm afraid that's a little bit beyond my skill set there, but hopefully I'll be able to figure that one out. So here's a view of the escapement and the little carriage shift mechanism here. And this thing, it looks like they had to make this a little more different than like a TK than I would have expected. Like with this unique little shifting mechanism for the carriage, there's no interlock here with the escapement or the keyboard, so I can technically enter numbers while this thing is like pushed down. So I'm not sure how I haven't run into that being an issue while I was using it, but I thought that was interesting. This little plate here, there should be, or there would have been, like a toothed rack that was facing upwards, I believe, and they just like removed it. So we have these 3 pins. The front plate here, I mean, this whole front area kind of looks like one of the really early TK ones from like the, I think, earlier mid 30s. But everything else, I've been having trouble placing, like, oh, what's this part out of? It's just this weird kind of situation up front. Okay, so here's a view of the setting arms back here with the keyboard. And there's the back of the rotor, so I'll just go through I think this is pretty standard on pretty much every facet, but there's a pretty good shot of it from back here. Let's see, so keys 1 through 4, we have the upper setting arm that's going to push down on each of the little individual pinwheel things. There's 3, 4, and then 0 is just kind of like a space. And then we got a 5, we go to the lower setting shaft. Oh, 6, 7, 8, 9. So, I mean, that's pretty standard, but, I mean, this thing is really nice because you have a good view of, like, the entire rotor, and then, pretty much everything else. And move my light. But, like, this thing, like, you can see the setting shaft, or the setting lever is, like, right there. Entering numbers again. And then on this one, you have a view of the entire rotor at almost every angle. So I'm probably not going to try any harder to remove the rotor. I was originally planning on doing that, but with the issues I had getting this thing out, I can get the sleeve bearings out, but this thing just was not wanting to come out, and I messed up the timing one or two times, and I had to figure out, okay, how do I get this exactly in the right spot? Um, I'll go over the carry shaft back here in these discs next. Okay, so with the carry shaft, I mean, it's pretty normal that you'll have what is it, the counter discs and then the accumulator discs right here. This is the little anti-reverse locking ratchet. I'm sure there's a better word for that, but we have this little guy, wiggly guy, and as soon as you turn this just far enough, which should be even less far than that even, it'll lock on the teeth. So you have to go all the way back around before you can do a different direction. And then, this thing is, again, I think a lot of this is pretty common, so it's not like this is specific to this model, but I think you get pretty good views of it with everything removed like this. There's a little clutch for positive or negative, so if you started going in subtraction for doing like a division or something, and I can get that all the way there, it will go. Oh, okay, that's positive. So they're all spinning in the same direction now. And then if I started doing subtraction, which that would have been, there we go. So now they're going in the opposite direction. I think the thing that's unique about this is you have 18 little carry discs on the accumulator section of the shaft. So that's kind of weird. Uh, they had to do two separate, like this shaft, this end here rotates, I think, twice as fast as this part. I didn't notice that in the beginning, but they had to do that, I guess, because the spacing on the little, whatever these are called, the carry nibs, little dingles right there, the spacing would have had them overlap if you had 18 of them. So I guess I'll get a shot of this from the front. I think the highest number they ever did, I believe, was like 16 without having the split shaft, and I haven't seen any other ones with the split shaft there on the accumulator, but you can see that like right here, they align when you're doing, what is that, a positive, no, it's a negative carry. Like all of these are lined up that way, and then, come on, there we go. Now they're lined up in the positive direction. It looks like all they had to do was just repeat like these four, what is that, four? Yeah, so they had to repeat these four discs and split it that way. There's a little component right here I removed that I'll put back on here in a second, but that was so I can get to the little carriage shift mechanism here. It's giving me so much trouble. Okay, so here's how I put this carriage together. Let's see. So here's the clearing for the accumulator on this side and the counter on this side. This looks to be pretty much the same mechanisms. This thing's made of like 5 different metals. These are brass screws, which I couldn't get that one out, so I couldn't get this plate off. But we've got, the chrome handles, chrome plated steel. We've got a milled steel down here. It looks like a different kind of steel for these components, this little lever. I'm not really sure why they decided to do that, but it did make some of these screws really hard to get out. Here's a back view. So we have the carry levers, like the standard Facit carry levers that are built into this thing. So they're right here, and they can kind of, I have a little magnetic screwdriver I'm using to open these up, but there we go. So those are going to interact with the little carry discs on the back side of this thing. Of course, we have the cast aluminum. I forgot about that. So a lot of different metals on this thing. I was able to get this plate off. I got another couple of these plates off, but not really too many issues with this so far. I might try to maybe like sand this down a little bit. This is the part that slides on those brackets. It's a little rusty. One thing it was getting a little annoying is this part right here. So this is the little, by the way, this is just a little thing that lifts up the rack that lets you shift the carriage there. And that's interlocked with a few of these things on the carriage. But when you are clearing oh, yep, okay, I think I just might have messed it up. So this is what I was talking about. This, what is it, accumulator clearing lever here? When this is removed, there's nothing to prevent this from going backwards, which is the wrong way. So if this lever gets shifted too far back, it will get out of timing with this gear. I just had to figure out that this spring had to be basically vertical on there to be on the right timing. And if it's, nope, okay, so we're out of timing again. So that's, oh, okay, are we, no, we're good. Yep, okay, so this thing, if that's out of timing, it won't let you clear it all the way, and then this has to be pushed. If this is pushed up, you're going to be interlocked there. So interesting that they interlocked this, but they didn't interlock the actual carriage shift. So you could still enter things and you could still technically spin the rotor, but you can't clear it while there's something going on with the carriage where it's not like in exactly the right position there. Okay, so before I put this thing completely back together, I wanted to get a shot of the carry mechanism thing on this with like the double shaft back here. So I have the carriage in the far, like as far over as it goes position, that direction. I have a 1 in there, so I'm just going to underflow it. And from this position, none of these weird little teeth right here and the double speed shaft, these are not going to engage with anything. It's just going to be the standard shaft back here, which I can't really move too well apparently. And each time a lever gets popped up with the carry, the way these things work is the lever is kind of has a bump in it that pushes the teeth on these over to the right. So they're all spring loaded and they all move to the right when they're pushed over, and then that will allow these to trip the gear teeth. And it has a little ripple carry thing that I'll show here. Alright, so subtracting, let's see, counterclock, am I doing it counter, it's hard to see this direction, okay. Counterclockwise, so this is going, I think the counter is going to trip first, I don't remember. Okay, so right now, there we go. So that's the first lever. Hopefully you're able to see that kind of back there. And I guess the bottom set of teeth is going to engage here, but pretty soon that one's going to get tripped. Okay, then we're going to start seeing the other ones come on. There we go. So now individually each carry lever is popped up, and then you can kind of see it now. Each time that happens, the tooth is moved, and we're almost at the end. And then the last one, the bell's going to ring. There we go. Okay, so to go back forward again, basically overflow it. Okay, first one got popped, and then they're all going to get popped in a row, and the bell gets rung again. Okay, so I'm going to shift the carriage over 10 so we can get the other half of the carry mechanism exposed. So that's as far as we go. Now we're in position, or I guess we're in position 1 up there. And there's 2 separate parts that weren't installed. I guess these are the new parts that are just for the extended carry here. There's this thing, this little rack of spring-loaded teeth that's cammed off of the rotor. And this only interacts with, or gets pushed out like this to mesh with these transfer gears, I guess like right at the end of a subtraction operation. So during an addition it still pushes out, but it's not engaging with anything really. And most of the time it doesn't. It's only when you're doing a complete underflow that those engage. Oh man, this flashlight's weird. Okay, so I'm going to go ahead and do a subtraction going from having 1 in the accumulator, so it's just going to be a normal subtraction here. No underflows or anything. And these little rack of teeth will engage at the end and then reset, and they weren't used because there wasn't any underflowing. But now I'm going to do the full carry with all 18, doing an underflow. I'll try to get a view of this. So, almost. And there we go. First lever is exposed. And now we're going to start doing the ripple carry. So we got these gone. And then let's see, where do they actually meet? This would be the last 9. Okay, so there we go. So right now, we have two carry discs, kind of trying to lay out them that are aligned. And right now they're going to transfer from the first set of carry discs to the last set that's going twice as fast. There we go. So that was a pretty smooth little transfer. And right here, now these little rack of teeth are engaged, which I'm going to show this here. It doesn't really seem like these do very much besides just kind of keep the teeth in that position, like they allow them to shift over as much as they need to. But I'm not really sure what else this thing does, to be honest. I mean, that's really all it does. So if I were to do overflow here, in addition, it doesn't even engage at all. Like these teeth will get shifted. It's only during subtraction, during a full underflow, that these things actually do anything. So right here. There we go. And that's it. That is the full extended carry. Alright, I got this thing finished. I think it looks pretty good. I was able to kind of touch up the paint, which isn't really a paint, it's more like a green plastic textured coating. The chrome looks a little better. It was a little too rusty to do a whole lot more with. I'm going to kind of start going a little faster here. I got to make sure I get this shot finished done before the little old lady next door sits down for dinner and realizes that somebody took her lazy Susan. So let's get a little bit faster there. So I noticed that this input register down here doesn't have the trailing zero cover that even the TK has. I think like pretty much all of these have that little sliding cover to where these would have been covered up typically. And this has a 10-digit counter, so they should have been able to cover all of them. But this thing just doesn't have it at all. And I'm guessing the idea with that is that this is for it's for scientific use. And you're a big boy scientist now using a big boy Facit. And so we're taking the training wheels off, and you're just going to have to deal with it. Okay, so I replaced the window material for the little number screens here, but I was able to fix the base plate by doing this. Check that out. That's polycarbonate. That's not just the base I cut out. It's that's for real. And you can see now the inner workings of this thing. Kind of. You got a big old aluminum casting here, and then this is gonna get filled up with grease. But until that happens, this thing, I don't know. You can kind of see the carry wheels. You can see. If I get a flashlight on there, you can maybe see the. I don't know. You can see the carriage shift. That's cool. That was the thing that was broken on this, so now I can quickly diagnose. Oh, is this thing working? Am I gonna? Oh, we got some grease coming up there. It's getting worse, but I'm glad I got this shot now because it's never gonna look this good again. Okay, so I wasn't able to find a whole lot of information on this besides that it was based on the TK, but has this sliding extended carriage. So I ended up getting a TK just so I could make a full comparison here for posterity. And I gotta say the size difference, I think, didn't quite get communicated properly in most of the descriptions I read. I mean, this thing is a lot bigger than the TK. And frankly, I'm not sure. I mean, in America, we don't get a whole lot of these facets, but I feel like these keys might be a little bit too small for me, just personally. But, you know, maybe I just need to get used to it. It's a lot more compact. This would definitely be easier to transport, I would say. Okay, so a benefit of the TK is it's definitely a subcompact, which means it's perfect for concealed carry. I might bob the handle so it doesn't get caught on like the waistband or belt when you're having to draw from a hip holster. I'm not quite sure. The capacity of this seems pretty large, but I'm not sure what the actual cartridges takes is. I've been loading it with 38 wad cutter. But unfortunately, it looks like because it's a rimmed cartridge, it's getting caught on the rim when I try to cycle that. I'm not sure. It might be 9mm or some kind of weird European cartridge, but I'll have to look more into that. I'm still trying to get used to the European keyboard layout. I think that with these American calculators, they knew that you needed to have them far enough apart so you could use your side arm to actuate the calculator to get a couple more inches of reach when you really needed it. Okay, so practical use of this thing, it seems like it's pretty helpful to have this extended carriage that moves up here. You don't really have the full control because this is, I mean, you can kind of do that, which you're not supposed to do. But I don't have a user manual. Maybe you're supposed to do that. That would be interesting. But let's say I want to do 39.5637, and I'll point that off there. And so I can point this off as long as I have enough room for the decimals. So I should have enough room there. Could just pop it over here. So you have a lot more control over where you want to put this. But I can just point that visually. So I'll do forward multiplication first. Okay. Okay, so that number squared is 1565 point all those decimals. And I can do the shortcut method as well, since it's already pointed off here. And you do have to kick it into addition first, and this thing doesn't quite have enough play so where you can do the like move it 2 millimeters and then go in reverse. So I'm just going to do it that way. And let's see, first one's 7. So I'll do this. That one's pretty good, and I'll finish this up. And there we go. So that's forwards and backwards multiplication. I like where this thing really shines is in division, when you have this many options of where you want to point things off and move this around. So let's say I wanted to divide a 10-digit number, which you can do with this, with the extended 10-digit entry there. And let's say I have that all the way to the left side, divided by 7. I have options where I want to put this. I could try to put that there. That would not work very well. Or I could put it here. I could point this off right there. I mean, you have a lot more room, I guess. This is I mean, assuming that you'd need to do a 19-digit number, which that would be insane. That they do make this so it carries 19 digits, so that it is possible on this. But I'm just gonna, I don't know, let's lazily put it right there, so that should be right at 10. So I'm going to go ahead and do this. Doing this the speedy way. Oh, I went a little too far. I'm not very good at that. So. Oh, too far again. There we go. I'm not super good with these hand crank machines. I'm gonna get this. Oh. So this is not a fault of the machine. This is just me being very bad at this. Yep, okay. So I'm gonna just keep going. Pretend that normal people that know how to use these are using this machine, and it'll be perfectly fine. Okay, last one. Oh, I'm scared to use this thing. Okay, so I have that 10-digit number as the answer with a remainder of 2. It looks like that's 2 and the 1's digit 2, so I could keep going. If I really wanted to, I could move this over. I could put a 2 right there and finish out this calculation, but that would, I don't think I would make it through that, honestly. I'm very bad at catching when the bell rings, but this is fun. So I really like this one. The only complaint I have in terms of using this thing is this little slider. So it's easy to go from 1 to 10, which, you know, if you're doing division, that's, you know, you have this way, and then you have the button for doing that, but it can be easier. But if you're trying to go to somewhere in the middle, the issue is the shape of this little rack here that latches in. So This is not rounded off down here. It's just flat bottoms, and it's spring-loaded. But the fact that it's flat means that if you're trying to go to, like, I don't know, position 5, you won't quite. Like, this has to latch in, and it's only like half of the, like 50% of this travel is actually going to latch in there. So it's not easy to tell that you're not latched in. Like this way, we're not. Then when you try to go do something, it's going to be locked up. And you have to go, oh, okay, I'm not fully there. And now the buttons are stuck too, so you got to move it over physically. But I mean, overall, these buttons are the same as whatever, normal Facit stuff. And it's not as hard of a push as I'd expected it to be. I mean, I don't know. That's kind of a silly complaint, all things considered. I mean, this is, I don't know. They didn't make too many of these, but I can say that I really do like this. Got a little dirtier because of the openings, that most Facits are like a sealed unit, and then this has, they did a pretty good job, but it's still open in the back if you let it sit like this. But I don't know, I think this thing's pretty neat.